Hello and welcome back to Advent of Code 2024, day 12. I missed yesterday, so I'll probably try and do that 11 later on. Hello, Umaro, Smab UK, DIJ. Apparently I was your most watched channel this year, 252 hours. That's like double my Satisfactory stream. Speaking of which, it's probably going to take me another 100 hours to finish Satisfactory, so that may well match up. Alright, so, day 12. We'll see if I can squeeze in day 11 as well later on. Garden groups. 12 is pretty easy. Alright. Looks like some sort of word search. Garden groups. Why not search for the chief historian near the gardener? This was last year's. Oh, this one with the bajillion maps. Which was not that hard, you just had to hook up all those maps. Yeah, I remember this. And his massive farm. Yeah, that's... Oh. This was another problem as well. Oh, this one. This one was a hard one, wasn't it? I think. Yeah, this one you had to be really careful about how you stitched all these maps together. Oh man, this is probably the one that took me the longest last year. There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching, they form a region. Horizontal or vertically. Okay. 5 different regions. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. Alright. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. Okay. Fine. Both easy to calculate. Visually indicating the sides of plots in each region that contribute to the perimeter using those. Okay. Yeah. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. The above map contains 5 regions, one containing all of the O garden plots, and the other 4, each containing a single X plot. Yep, alright. The 4 X regions each have area... Sure, alright. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. Alright. That's an odd calculation. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. Alright. So, yeah. We just find regions. And... okay. Seems straightforward for part 1. And it doesn't even look too horrible either. That actually looks pretty reasonable. What's this say? Merry... Eerie... Hairy... Are they trying to say Merry Christmas? Alright. Almost looks like some ASCII art. It could be. I like lean back and squint. I don't know. Just looks like a camouflage flag of some sort. Alright, so I guess this is kind of a flood fill problem. So I can definitely reuse. So from 10 we have this stuff. In fact, I can reuse quite a lot of this. Even DFS actually. Maybe. Let's just copy that in and see. Alright. Grid with open grid.append. So this is going to be strings. So we just do line.strip. Okay, and then we've got pause, we've got add equality hash. That's probably all we need. Is inbounds, we've got that as well. Get neighbors, yep, we've got that as well. Okay. Yeah, so what we want to do is we want to find all okay, get rid of these peaks and ratings things. So Q equals start, while Q current equals Q.pop, the same as before, but we want to get rid of this. So this is a flood fill, so it's an exhaustive search. We don't have a break condition. Current equals Q.pop. So we want to know the type of plant. So plant type equals grid. And we want a set for the region. Let's just call it, make that set. Alright, so while there is something on the queue, pop it out. Yeah. For neighbor in current.get neighbors, if grid neighbor ij equals, it's the same plant type, we pop it back on the queue, and we probably want to add it to the region. Alright, we need, now this will go around in an infinite loop. We need to also say if neighbor not in region and there we go. And then when we've done that, return region. So let's test this out. To print DFS just from 0, 0. So what it should look like is a bunch of Y's, which is sort of hugging the left here. So we should have lots of... I should go up to like 11. Okay, let's have a look. Yeah. Yep, looks about right. Okay. So, what do we do? I think, Alright, so we need to populate a list of all cells, because we need to exhaust them every time we find a region. Those cells are no longer candidates. So let's say candidates equals the set of pos I j for I in range n for j in range m. Is this... Am I allowed to write comprehensions like this? Yeah, okay. So that contains everything. $140 times 140 is indeed 19600. Okay. So that's all the candidates. So we want to basically, while there are still candidates, how do we... how do you do this again? How do you get something from a set? Now, we don't want to cast it to a list. That's just wasteful. Let me look this up. You can do something with a next iterator. It's a bit weird. Python get an arbitrary element from a set. There's a few ways to do this, but or you could do pop. I suppose pop is fine. All right, so start equals candidates.pop. Region equals DFS on that start. Also, the region should also contain the start. Alright. Region equals DFS on the start. Candidates minus equal region. So we want to now discard all those because they're all covered. That's one region. Let's just see if this actually... Okay, finished. So I assume it found every region. So for a given region, calculate pricing. So the area equals the length of the region. That's the easy one. Parameter, suppose we have to let's make a parameter of a set. We want to say or positions in this set. Well, okay, so we're accumulating perimeter here. So normally this position would contribute 4 to the perimeter because it has 4 sides. So perim equals 4. But for each neighbor that is already in the region, we have to discard one of those edges because that's not on the perimeter. So basically we go for neighbor in key.get neighbors if grid neighbor.i neighbor.j is the same as... No. We've got the region right in front of us. We're saying... if neighbor in S prim minus equal 1 result plus equal prim. We could actually simplify this. We can say equals 4 minus the length of, so it's going to be S, it's going to be the neighbors, cast it to a set, minus S. That's it. So basically, we take the neighbors, most 4, and we just discard any which are in this set. And then we're left with the outer perimeters. Okay. That's a one-liner, really. Return, and this could actually be made into one line, but we'll just separate it out like that. Return results, so that's the perimeter. So area is that perim equals let's say get perimeter. Perimeter of the region. So then what? The price is those two multiplied together. Okay. Let's just say part 1 result, or just say total price equals 0. Total price plus equal area times perimeter. Okay. Big number. Yep, seems about the right magnitude. Actually, I was expecting it to be bigger. I'm not sure. No. Oh, it's too high? Okay. Let's go for... $140 for the first example, A, B, C, D. What, this one? Okay. Wonder if I'm using these set operations correctly. I think that's how you use it. Also, should I be bracketing that? Don't think it would matter. Okay, so... $149. So I got an extra... region or something. Let's print... print start and the region. Let's just do that. So we got 1, 2, 3, 4, 5 regions. Okay, yeah, so it is 5 regions. Alright, where do they... Okay, the first example, region A has price 4 times 10 equals 40. I suppose we want to just put this down here. It's probably the perimeter calculation which is wrong. That seems to be the most... So... Oh. Let me also print the letter so we know which one we've got. Grid. Okay, so these numbers are wrong. A should be 4 times 10, not 4 times 12. B should be 4 times 8. We've got 4 times 9. Wait, what? No. A should be 4 times 10. We've got 4 times 12. B should be 4 times 8. We've got 4 times 10. C should be 4 times 10. We've got 4 times 9. They're all off by 1 or 2. D should be 1 by 4. Got 1 by 1. Okay, I think the perimeter is definitely wrong then. 3. E should be 3 times 8. Well, that one's correct. Oh. Hang on. Yeah, the perimeter's wrong. Okay, so let's just go through this perimeter calculation again. How did I do this? For each position in the set... Wait, are the sets right? Maybe the sets are wrong. So A should be 0, 1, 0, 2, 0, 3, 0, 0. Correct. Alright. So when we calculate the perimeter, I did 4 minus the length of that set minus that. So it should be at minimum 0 and maximum 4. Alright, let's print these numbers. Michael PC Gamer, thanks for the raid. Did you just do this? I think I've got mostly the right stuff. It looks like my perimeter calculation is wrong, so I'm trying to fix that now. Perim equals that. Result. Welcome in Stu squared. Plus equal perim. Return result. Alright, let's try printing perim. See what's happening here. Three, 3, 3, 3. That's wrong. Three, 3, 3, 3. It should be 3, 2, 2, 3. What's going on here? 4 minus... Alright, print set of T. Am I even computing the neighbors correctly? Print neighbors. 3, 3, 2, 2. Mine was just tuples with length. Very simple. What on earth is going on here? So... And if I subtract S, three, 3, 3. I don't know what's going on here. Is this even the correct operator for set operations? Maybe I'm gonna have to look this up. Python set operations. Oh, that might not be the right operator. Intersect that's correct. Minus. Alright. I just have to break this down then. Let's say... perimeter. Maybe the set is wrong. Oh no, we've already printed the set. That's the set. 01, 02, 03, 0. Okay. Okay. And then we're doing the set of... So for P... Alright, let's print P as well. P is this one, 01. So we're saying we want the set of all neighbors, but discard all the ones that are in the same region. So we're just left with 1, 1. Oh my god, I know what the problem is now. It's because it's on the side of the it's not counting neighbors. Because the way we designed POS was specially for problem 10. That's what happens when you copy methods forward from past problems. But we don't want is inbounds here. Take that out. So it was not counting neighbors off the side of the grid as a neighbor, but it should, really. Wait, should it? Oh no, that might not even be the problem. Got P01J. Oh, I'm just going to have to print these all out. So we got P. That's its neighbors. So we discard 0, 0 and 0, 2, and we're left with 1, 1. Okay. So we end up with 3. Because we subtract 1. I don't get this at all. Oh, it's the other way round. I should be subtracting the 3, not the 1. It's intersection, not subtraction. Ah, set operations, always confusing. Is that right? So we want that? Minus all... Minus... Yeah, why did I do minus? We want to find all the neighbors which are in the region, and each of those get discarded. So this should be... What do you do in set? You... Intersection, it's and? Let's try that. Yeah, that was it. Why did I do minus? I must have been thinking in my head all this time, that's intersection. Okay. But it's not. Alright. That was weird. There we go. 140. Alright. Should be able to do this now. Slightly smaller. Okay. Part 2. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Consider this example again. Region containing type A plants has 4 sides, as does each of the regions containing plants of type B, D, and E. However, the more complex region containing the plants of type C has 8 sides. Okay. So... So it's essentially the perimeter, but then you filter out all the sides which connect. Oh boy. Wait, so the region has 4 sides, so there's the top, the bottom, left, and right. Okay, I see. Alright, so... Nothing else? Alright, so we have to do sides. So I guess we want a new method here. Okay, so instead of subtracting numbers here, let's just store sets of all the sides we found. How do we define a side? I guess, how do we define an edge? I guess the pair of positions which the edge separates. So let's say we want, instead of this, we want that out. So we will, okay, go back to saying perimeter is going to be a set. Key in S. So we say we'll get rid of this logic. Okay, so for each neighbor, for Alright, in this case we do actually want to... yeah, let's stop going inbounds. We want to count the cells which are outside the grid as well. This will just make it more convenient. So just take that out. That means we have to change DFS. We have to save for neighbor. If not neighbor dot is inbounds, continue. Right, do we get the same result? Yes, we do. Okay, so now PMS, we'll say for neighbor in p.getNeighbors, if neighbor not in S. We're going to add that to our list of perimeter edges. Maybe I should just call this edges. It's not really a... And we'll call it perimeter edges. Okay. Add... What are we going to add here? It's the pair. So I guess we want to sort it. Tuple of sorted p neighbor. So it'll sort them and then... Oh, we don't have a way of sorting. How do we sort? Okay, we'll have to do... define less than other turn self.I self.j is less than self.j other.I other.j. Alright, we got a way of sorting. It doesn't matter as long as it's consistent. It doesn't matter what the method is. So self.I, self.j is less than other.I. So it will use lexicographic or whatever ordering. So now sorted should be able to do its thing. Oh, we need edges. Okay. Alright, so we've got a perimeter. Set of perimeter edges. Now what? We want to filter out what we're trying to do. So we now know what the full perimeter looks like. So whenever we have an edge and it's connecting to an edge, that will mean the two cells either side of it are kind of lined up. Is that all? That's basically how we work it out. Or We can just say we keep all the ones which are either leftmost or bottommost. So for any line of edges which are in a line, there has to be one which is at the leftmost. That's the only one we count. If we do that, then that should work, right? That will show we only add one for each of these sides. And if there's two sides which are separated by a gap, they'll each have a leftmost edge. Alright, let's see if we can do that. So we say so we're just going to create a set of sides for P1, P2 in perimeter edges. Alright, so we take each perimeter edge and we're going to work out whether it's a leftmost or bottommost. So, in which case are we going to check if it's leftmost? If P1 and P2 are vertical, so that's like if P1 P2 dot I P2 dot J equals P. Yeah, no, just like P1 dot J is P2 dot J. They're in the same column. All right. In this case, we're checking that this the leftmost. So we want to say if. Then we want this. Tuple sorted. There's got to be a better way of doing this. All right, tuple sorted. We want P1 minus so we just move to the slide to the left by 1 and see if that's also in the perimeter. P2 minus pos 0, 1 is not in perimeter edges. Sides dot add. We're just counting them, aren't we? Sides plus equal 1. Okay, I don't really like this logic. Let's see if it actually works. Return sides. So part 1 was this, or just this. Part 2. What are we doing? So what did they call it this time? Oh, it's like new pricing. All right, we'll say put total price 1. Total price 2. Oops. Equals 0, 0. So that's total price 1. Total price 2. So sides equals get sides region. Total price 2 is area times, what was it, sides? I'm gonna check this. To calculate the price, you need to use the number of sides each region has. So it's just the same calculation but with sides instead of perimeter. Alright, we'll try that. Tuple sorted minus. Oh, I didn't. Wait, I took out the minus. Didn't think we'd subtract. We did subtract. All right, it's a smaller number, which is to be expected. But nope, it's too low. Okay. So we got the perimeters correct. So we need so we want... Oh, I didn't do the bottommost case. So we've got basically half the sides. We've only got the horizontal sides. Else, we want the same thing, but 1 0 1 0. Okay, it's a bit bigger. That's still too low? Oh. Alright, now what? Alright, let me just run through this logic again. So we get the perimeter edges. Yeah. We're saying... Alright, let's try this in the test example then. So we're saying 80. What did they say? 80, that's correct. Okay. So, go to example 2. Or the O's and the X's. Seven, 7, 2, 4, 3, 6. Correct. Okay. So the second example is correct. Let's try the third example. Two, 3, 6. Correct. The third example is correct. Fourth example. This is the last one we have. Three, 1, 2. Okay, this one's wrong. This should be 3, 6, 8. Alright, so this one's wrong. Let's print out the sides. Print. So it's grid start.py start.j we want the area, perimeter, sides. So A, we got 28, 40, 10. B, we got 4, 8, 4. So 4 is correct for the number of sides for the B's. For both of the B's. A single region full of A-type plants with 4 sides on the outside and 8 more sides on the inside for a total of 12 sides. We've got 10. We're missing 2 sides. Okay. So we're close. Want a hint? If you think there's a relevant hint, yeah, sure, you can give me a hint. Oh. So this should have What, 1, 2, 3, 4, 5, 6, 7, 8, 9 sides? But that diagram that you've drawn there, I don't know, I think I would be capturing those at least according to how I understand my algorithm. Alright, let me count the sides. So we've got 12 sides and we're missing 2. So it's going to be something weird, like where they meet in the middle here, because... Oh. Alright, I see. Yeah. We've got one side contributed from the A's, above the A's, one side below the A's, and that's the same side? But, alright, let me read the description again. What exactly did they mean by side? Each straight section of fence counts as a side, regardless of how long it is. So this shouldn't be a problem. So this whole thing is one side. And then we've got one down the middle. Alright, so what other sides? There's the top, the very top, the very left, the very bottom, the very right. That's 4. Then we've got one going vertically through the middle. One going horizontally through the middle. And then one... Basically, each of the B's... Oh, well, that's not quite true. Okay, so what did I say? There's 4 around the outside. Then there's 2 crossing through the middle. And then 1, 2, 3, 4... More? So what did I say? 4, 2, 4... 8, 10... That's what I've calculated, so I've just done something wrong in describing it. Which edge am I missing? Which 2 edges am I missing? The plus, but that's just 2 edges, isn't it? According to their description. It's one piece of... It's a straight piece of fence that goes all the way from... The edges crossing the center count as 4, not 2. What? So each straight section of fence counts as a side, regardless of how long it is. Wouldn't that be one long section of fence? Like if you're literally... It's broken in the center? I guess my understanding of fence is like, I don't know, like in Minecraft, where if there are 2 pieces of fence and they're the same way, then that's a fence. I think it's 2 fences, both of which make a 90-degree turn. Alright, if that's what they meant. I don't think the sentence is actually clear enough. Like, if I were placing fences in a grid, to me, it would be identical to if I were to place a fence around a corner, and then a fence around a corner the other way. To me, the end result would be exactly the same as if I placed one long fence and one fence crossing it. Okay, fine. And they specifically said regardless of how long it is. That's what made me think that that would count as 2. Think of it as the fences owned by the dudes who own the smaller squares, maybe. We even count the fences between 2 neighboring regions. They want their own fences. I mean, it makes sense if there's a gap between the corners. Like, so there's one fence going like this and one fence going this, and then there's a literal gap between them. Then it makes sense to me that it's 4. But the fact that we're placing these on grid lines where they kind of intersect, because that's where the grid lines are. I don't think of there being a gap, but okay. I get that this is what we're supposed to do. Alright, so then... So then what do I do? Suppose... we have to distinguish... Alright. In that case, I need to just... this ordering, I no longer... So when I did this sorted thing, the whole reason I did... this was to tie those 2 together, because I actually wanted those to count as 1 instead of 2. So sorting would make it irrelevant whether the neighbor is above or below. So now if I remove the sorting, I guess that should work. So I want E. So it's actually simpler. I actually added that step to intentionally tie those 2 together. So I add P neighbor. So we're always saying the left one is in the region, the neighbor is out of the region, though the right hand side is out of the region. So now this is in, this is out. So we want if so just this then? $368, that's right. Oh, damn it. So it's actually simpler than what I did. My interpretation. Simpler to code for. You don't have to do this clever thing where you're what's the word? Oh, there's a word in mathematics for quotient something, I don't know. Alright, let's try this. Nine two one six three six. That was similar to something I had before, but I guess it's off. It was just a little bit off. Yeah. Okay, a bit bigger. Okay. Let me read the description of fences again. I'm not sure whether I really agree with that interpretation. Oh, I did skip over this paragraph, didn't I? Be especially careful when counting the fence around regions like the one. Okay, fine. Basically, it's just explained in this paragraph. I didn't even read it. Although I prefer if they put that in the original description of sides. Like, seems like they've used a very generic description of sides here, and then way later on, they actually explain the full definition. I normally skip the examples, because if I get the definition, then I don't really want to read the examples, but okay, fine. Alright, how much time do I have? I could try and go do day 11 now, because I missed that one out. I often dislike problems that require lengthy explanations myself. I think it's more a case of the structure of this. Like, I always want the definitions to be in one place and examples to be in the other place, so that I can skip the examples because it takes forever to read them. But it seems like they've worked the definition into the last of their 4 examples. Which I don't like, because I wouldn't have read this if I got the first 3 examples, and didn't even read the first 3 examples, but if all the definition had been in one place, I wouldn't mind if it was lengthy. This is why, in one place and brief, yeah. This is why I would prefer if they would sometimes use more mathematical descriptions instead of words. Like I can't think how you'd explain this mathematically. Well, okay, actually the way they said inside and outside, that's actually a pretty good definition. It's just in the wrong place. Do you put your solutions up somewhere? I'd like to refer to them as I'm practicing Python. So when I post the video, YouTube video, I put the I put the Gist link to. I put the problem on my code on Gist, and I put a link there, so you can check my YouTube channel. Here. So I post the videos of these, and then in the description of the video you can find the link to the code. Comprehending your customer's description odd is a problem is part of a coder's skill. I suppose I've never been a coder that had to work with customers directly. That's what we have sales people for, at least in my past company. So, but yeah, I suppose. All right, so that's that. All right, I gotta go back and do day 11. I'm not sure that I'll do it now, actually. I think I'm going to take a break, sort some things out. I might come back later in the next few hours and do day 11. Was day 11 good? I can take the briefest of sneak previews right now. It looks like some sort of number theory problem. Alright. Alright. Thanks for watching. I'll be back in a few hours to finish off day 11, and then I'll be all caught up, hopefully. Tomorrow I've got to fly again. God, I keep disrupting this, so I don't know if I'll be streaming tomorrow. Well, I'll be arriving in Bangkok Usually internet is good there, so should be okay. 11 was easy from what I remember. Alright, that's good. And then I should have time today to do both. Alright. Let's check if anyone's still doing Advent of Code. Inveil Code. That's in French. Nobody's doing it in English. Alright. Alright. Then, no raid. Oh. Yeah. Okay. Thanks for watching. Bye-bye.